A production system can be seen as having two major parts: manufacturing support system and facilities. Okay. The manufacturing support systems are the planning and management side. These include product design, manufacturing planning, manufacturing control, and business functions. This part decides what to make, how to make it, when to make it, and how to monitor performance and quality. The facilities are the physical side of the factory. This includes the factory layout, production machines, and material handling equipment. In simple terms, this is the shop floor where the actual production happens. A good way to understand this is to think of the support system as the brain and the facilities as the body. The brain plans and controls while the body carries out the work. In real industrial practice, problems often occur when these two parts are not aligned. For example, planning may demand output that the machines cannot realistically achieve, or the layout may not support smooth material flow. Now that we know the structure of a production system, let us look at the actual operations performed inside manufacturing. Manufacturing operations can be broadly divided into processing operations and assembly operations. Processing operations change the work material itself. They may alter its shape, dimension, physical properties, or appearance. For example, machining a block, heat treating a gear, or coating a surface changes its kind of properties. Assembly operations join separate components together to create a more complex product. For example, fastening parts with screws, welding metal parts, or assembling an electronic device. A simple example is a bicycle. Making the frame tubes or machining the wheel hub are processing operations. Joining the frame, wheels, brakes, and chain together is assembly. Most manufactured products involve both. First, individual parts are created through processing, then those parts are joined through assembly. So let us first focus on processing operations and see the main categories inside them. Processing operations can be grouped into shaping operations, property enhancing operations, and surface processing. First, shaping operations change the geometry of the material. So this includes casting, molding, forging, machining, and similar processes. These are used when we want to create the desired form or dimensions. Okay. Secondly is property enhancing operations, which improve the material's physical or mechanical properties without significantly changing its shape. Examples include heat treatment and sintering. So, for instance, a gear may already have the correct shape, but still needs heat treatment to become harder and more durable. Okay, third is surface processing. So, surface processing improves or modifies the surface of the part. This includes cleaning, coating, plating, polishing, or surface treatment. And these are important for corrosion resistance, appearance, friction behavior, or cleanliness. So, in practice, one part may go through all three stages: first shaped, then strengthened, then finished on the surface. So once the individual parts are ready, they must often be joined together, and that brings us to actually assembly operations. Assembly operations are mainly divided into permanent joining and mechanical assembly. Now, permanent joining creates joints that are difficult or impossible to separate without damaging the product. Examples include welding, brazing, soldering, and additive bonding. These methods are used when a strong or permanent connection is needed. Mechanical assembly uses fasteners or joining methods that can often be disassembled if needed. Examples include screws, bolts, nuts, rivets, and press fitting. These are useful when maintenance, replacement, or upgrading may be required. For example, a car body may involve welding for structural strength, while its engine cover may use bolts so it can be opened during servicing. So the choice of assembly method depends not only on strength, but also on maintenance needs, cost, production speed, and product design. Now we move from types of operations into an important production strategy question. How much are we producing?